Hello everyone. Today I want to share with you my research on making blockchain more sustainable. This project links directly with the modules that you are studying. Before I explain more, I want to highlight something important, which is the value of learning Python language. It's a tool for innovation and it connects to real world applications. Did you know that Bitcoin mining consumes more electricity than some entire country? That's because traditional blockchain mining requires solving very hard puzzles again and again, and that consumes huge amounts of energy. So the big question is, can we make this greener and more efficient? And how can Python programming help us explore the solutions? So blockchain is a digital ledger. To add the entries, miners solve cryptographic puzzles, and this system is called as proof of work. These puzzles require massive computing power, which makes blockchain slow, expensive, and also environmentally damaging. Let me show this simple algorithm in proof in Python to show or demonstrate the traditional proof of work. So in this code, it keeps testing the numbers called nonces until the hash starts with four zeros. If in this run, if found the solution at nonce 88,484, the resulting hash begins with four zeros as required, and the whole process took about like 6.3 seconds over here. So this gives us a hands-on way to see why mining takes so much energy and it requires a huge numbers of repeated calculations. That's exactly how blockchains secure blocks, just at a much bigger scale. Now, my research explores how blockchain mining can be distributed using edge computing. Instead of relying on giant data centers, edge computing processes data closer to where it is generated on IoT devices like phones, mobile phones, industrial robots. So what's the result? Around 25% less energy and 50% faster processing and improved scalability. Now, how do we test this? We can write a Python code. Each process can act like an edge device, so we can make sure that it computes locally and it is faster and more efficient and it is less dependent on a central system. Now let us simulate Bitcoin style mining, but instead of one process doing all the work, we can split it across multiple Python processes. Now what we do is we slightly modify the code here. Each worker acts as an independent edge device. The mine block function repeatedly tries different nonces until it finds the hash that begins with four zeros. Now we can use the Python's multiprocessing pool where we can have four workers mine simultaneously. Now, as the results show, each process arrives at the same solution, but the overall computation is completed much faster due to the parallelization. This demonstrates the concepts of edge distributed mining, faster and more energy efficient. Now, our expected outcomes highlight up to 25% energy savings, 50% lower latency, stronger decentralized security, and as much as 35% cost reduction. However, there are challenges ahead, such as keeping blockchain nodes synchronized. We need to understand the regulatory and privacy compliance and manage the limited power on the edge devices. So looking forward, there are lots of future opportunities, for instance, like AI-driven optimization and seamless IoT integration. So in conclusion, edge computing offers a promising path to make cryptocurrency mining more sustainable, efficient, and future ready. Though scalability and security still need further research. Thank you for listening. I hope this encourages you to see coding not just as a problem solving, but as a way to create ideas that can make a difference. If you'd like to learn more, here are a few resources that I want to highlight here. You can find my research papers on my IEEE Explore author profile. I've also shared the demo codes we used today. You can try them on the CodeEdX platform or view the full project on GitHub. You might even experiment with other hashing algorithms in Python to compare the performance. Have a nice day. Thank you once again.